Unmute, huh?
There's a white board. What shall I switch it off?
Doesn't matter, sir. It's fine. Hello, good morning, everybody. Thank you for tuning into the Central University of Punjab's official YouTube channel. On the onset, today is a World Oceans Day, and a warm welcome to all of you. We all know that the oceans play a major role in the entire planet-wide ecosystems as well as for communication, everything, including 65% of the oxygen in the atmosphere comes from small, microplanktons, right? This is something called phytoplanktons of the ocean. So majority of the oceans that we inhale, the oxygen that we inhale comes directly from the planet Earth's oceans, And of course, we know that ocean cover almost 72% of the planet Earth's atmosphere. So today is a day to pay the gratitude to the world's oceans, So oceans are really important, we know it. And here in this Central University of Punjab, we have been working. So could you please mute all of you? I can hear some background. Majority of the oceans that we inhale. Okay, so today we have this particular program. This is World Oceans Day. We have our chief guest, esteemed Professor Vinod Kumar Gaur. Professor Gaur is former secretary of the Ministry of Earth Sciences of the Government of India, the Department of Ocean Sciences earlier. And he has a wide experience. He is a giant, I tell you. And his first talk is entitled The Planet Earth's Oceans, Its Flywheel. And this talk will be followed by an international quiz competition. The theme of this quiz is oceans, right? So please stay tuned. And those who would like to have the participation certificate, just have a look in the chat box. I'll be sharing the feedback link. So there is no registration required. So to introduce Professor Vinod Kumar Gaur, I'm not the right person, but I will try my best because his achievements are really, really profound. And this event has already been registered with the United Nations World Ocean Day page website. And as you can see that this is in the page of the UN. So the event has two programs, as I told you, invited expert lecture by Professor Gaur, and then, we will have the quiz competition later. Professor Gaur is former secretary of the Ministry of Earth Sciences, Government of India. He holds his PhD from Imperial College London, one of the most prestigious institute worldwide. And subsequently, he did his postdoctorate at Paris Sorbonne University in France. In Paris, the topmost university in France. And before that, he was born in Varanasi in Uttar Pradesh, and his education, the college education, was in Benares Hindu University before going to the Imperial College London for his PhD. And he has won so many accolades, including Shanti Swarup Bhatnagar Award, which is touted to be India's Nobel Prize. And he's fellow of all national science academies in India, as well as the most prestigious international academy for the scientists called TWAS, the World Academy of Sciences, based in Trieste in Italy. And many more international accolades Professor Vinod Kumar Gaur has. And he is best known for his extensive contribution to the field of seismology, geodesy, and electromagnetics, and especially he's known for his prediction of April 2015 Nepal earthquake, and as we know that it was one of the most catastrophic earthquake in 2015 that hit the Nepal with more than 9,000 catastrophes. But yes, science does this work, right? He, according to his models, he did a prediction of this, the earthquake. That is a great achievement. And he is the first scientist who have used a GPS to calibrate the velocity of Indian plate moving towards the Eurasian plate. We know that it has a process which started 55 million years back to 45 million years back that has given rise to Himalayas. We know the Himalaya is growing, right? So this the plate tectonic velocity, how much is the speed of this Indian plate moving towards the Eurasian plate, is first time calibrated by him. A great achievement indeed. In 1971, he won IIT Roorkee's Khosla Research Award, 1979 Chandraswarup Bhatnagar Prize, 1979 IGU Krishnan Medal, and in 1996, he won MOM Award of Excellence, 2000 AGU Award, AFIN 3 Award, and in 2006, he won ISC Meghnath Saha Birth Centenary Medal, and in 2007, he won INSA DN Wadia Medal. And his achievements are really long. I will share the link in the chat box. Please have a look in his Wikipedia page. Earlier, he was working in so many institutes, including National Physical Laboratory, Indian Institute of Technology, Roorkee, National Geophysical Research Institute, where he served as its director, Indian Institute of Astrophysics, and right now he is working as Professor Emeritus at CSIR 4th Paradigm Institute, which is housed inside National Aerospace Lab in the Bangalore. So this is his wiki website. So I will share that link, soon in the chat box. So please have a look. So on the onset, a very warm welcome to you, sir. I'm really privileged to have you with us in this World Oceans Day. What more we want? The giant of the person who served as the secretary of the MOES. So over to you, sir. We are eagerly waiting to hear from you. You may please unmute yourself, sir. Yes, sir.
Can you hear me now?
Yes, sir. I can hear you.
Well, at the very outset, my greetings to all of you, to your Vice Chancellor and all the faculty of the university. Situated where you are today, you might consider yourself as being too far from the ocean to worry about its structure and what it does to our civilization, how it sustains it. But millions of years ago, you were not very far from another ocean, which is now buried under the Himalaya, the Tethys. And that was nearer to the northern shore of the Indian continent. And this will incidentally enlighten you about how oceans reconfigure the continents into new geographies. So that Punjab, which was lying south of an ocean, is now far away from the oceanic shores of India. The oceans indeed are a lifeline for the designed world. It's a flywheel of the Earth system. A flywheel is a large capacity reservoir of energy and materials, which are constantly circulated. And then along solar-powered gradients, thermal gradients that are created by the non-uniform shining of the sun on the Earth, moves the winds move the oceans, and the oceans move large quantities of heat material across the globe, and thereby make sure that any fluctuations that take place in our atmosphere are damped. And this is very important because otherwise we would have storms most of the time and catastrophic environmental problems. So that is why the planet's oceans are considered to be its flywheel, and because they temper the fluctuations in the temperature of the atmosphere by absorbing heat when there is an excess of it and releasing it when there is a deficit of it. They temper the Earth's atmosphere. They are indeed the planet's thermostat. And if you look at the next slide and ask yourself as to which of these 9 planets is our home, you can very easily recognize it. And how do you recognize it? Essentially by the face of its oceans. This is the third one over here. And you can see that the oceans reflect the blue colors, which can be seen from space and has been photographed by space travelers. And they distinguish the planet from all other planets, which apparently have no oceans. So oceans perhaps hold a clue to many of these puzzles. Why don't other planets have oceans? And besides, if we look at the if you look at the Earth face over here, it is patterned. You can see the Arabian Peninsula there, and the Indian continent also covered by the clouds, the African continent, and on the other side, you have the other continents, clearly marked continental fragments surrounded by the oceans. Next to it is Venus, a close neighbor of about the same size as the Earth is, and sharing the same genetic material in terms of chemical composition, but we see that it is featureless. There are no distinctive feature on its surface. Why? And what we have now found out is that the ocean also has a crust, like the crust of the continent on which we live, but the oceanic crust is much thinner. And this has been found by probing the oceans with earthquake waves. So why are they thinner than the continental ocean? So many of these questions, and liquid water holds the center stage of these issues, whilst science allows their exploration from first principles. So since this talk is being given to the university audience, I would take you briefly through these first principles, which give us a rational explanation of why things are as they are. The next slide shows you, for example, as to where the liquid water would be possible in space, given the size of a star, because the size of a star determines its luminosity L, and the luminosity determines as to what will be the flux of radiation, and the flux of radiation will then be distributed over spherical surfaces away from the star, and therefore will be proportional to the inverse of the square of the orbital radius. And this must be equal to the fourth power of temperature multiplied by Stevens constant, which is a physical law. So we can calculate T given L and plot this diagram that you see over here, and plot the limits of the temperatures which will allow liquid water to exist. And you see that liquid water corridor in space is really limited. The Goldilocks planet on which we live is fortunate enough to be right in the middle of it. Mars lies just outside it, and Venus, a little nearer to the sun, also escapes it. So we can see this puzzle of why liquid water does not exist on other planets, simply because the temperatures existing are either too high, so that it can only exist in the gaseous state, or too low, so that if it happens to be there, it will be in the frozen state. So that's one question that is easily resolved. And we approach the other questions again by looking at the first principles. We saw in the previous slide that the interior of the Earth is warm. And of course, that's a conclusion which even the primitive people drew just by looking at the occasional spewings of hot materials and gases in terms of volcanic eruptions, which gave a clue to the internal heat of the Earth. So we know that the Earth is hot inside, and heated bodies must cool. They must transfer their heat to the surface. So how did all this happen? Where did the heat come from? And I take you to the next two slides from the very beginnings of the formation of the Earth, starting from the solar nebula, which you will see in the slide, which is right on the left top corner, where you have clumps of dust which are a part of the solar nebula, that star from which sun was assembled after that parent star had burst, it has spread its dust and heat around, and these little clumps of dust started coming together as they moved because there was an explosion and a high velocity was imparted to these particles, which went round and round the central part, which contained most of the mass of this exploded nebula. And therefore, as the materials moved around and collided with each other, they clumped into larger planetesimals, as you see here. And the larger they grew, by their gravitational field, they cleaned up the material around them. So we come to protoplanets. And here is a computer in the lower half. You see a computer simulation where you put about 100 planetesimals orbiting the sun, giving nothing else to the computer to go by except the gravitational field, which is the inverse square according to the inverse square law. And just you see what the computer does given the random velocities, and it shows how within just about 441 million years, we'll be left with a few planets, the rest having been, all this other material having been swept into this by gravitational vacuum cleaning. So that is the process whereby the planet Earth evolved. And once it evolved, once it got organized with very little material left around it, which will be otherwise impacting the Earth as meteorites. But when they brought their heat and kinetic energy, and in times of heavy blanketing, all that heat was buried inside. And later, as the Earth's material compressed under the weight of its growing gravitational force, it generated more heat, like air in the bicycle pump, and the Earth became hot. So we go on to the next slide to see how the Earth first became a little softer. And as it became softer, the heavy materials will gravitate to the center. They will, like lead, heated lead through wax. It is going and concentrating here, forming a core. This happened to many planets. But the Earth was endowed with just the right mass and the right distance from the sun. The right distance from the sun made sure that it has liquid water. The right mass will make sure that it has just enough radioactive inheritance from the parent material, which will melt it and outgas the volatiles in the right sequence. So with this series happening as the Earth is becoming warmer, outgassing is taking place. And in time, when the outgassing has created an atmosphere, which is largely argon, carbon dioxide, sulfur dioxide, and nitrogen, the Earth will become a little warmer after that because more radioactive heat is being generated. And that warmth will then fire the kiln of hydrated minerals. The hydrated minerals in the Earth are like the kiln, the pottery kiln, which will be fired only at a certain temperature. And when that temperature arises, then the waters are liberated and we have the formation of the oceans. So this is how the oceans came into existence almost 800 billion years after the beginning of the Earth in this form. So the next slide will show us that this liquid water, which is trapped in the Earth, really helps structure the Earth in a particular way. We have seen how the core will be formed, and then around it will be lesser dense material and even less dense material above it. But as we go towards the surface, the temperature also decreases. And as the temperature decreases, the material becomes, changes its phase from being molten to near solid. And the presence of water will determine as to where the melting will stop and the solidification will start depending on the melting point of the materials over there. And what we have learned from scientific experiments that water in the molecules, they lower the melting points of the Earth's rocks. And this is a critical factor because what it does is that it creates just beneath the surface of the Earth at a depth of about 100 kilometers, a molten layer across which towards the surface, the material becomes brittle. So the next slide shows how this happens. This is that material over here. And this is, as you can see, this is the brittle material. And it is very akin to what will happen if you actually took a tray, a large tray, put wax on it and began melting it. You will actually see this kind of convection currents forming. And the Earth acted in precisely the same manner. Wherever the heat was a little more because there were materials on the surface which were insulating enough, like continental materials, and blanketed a lot of heat. At those points over the mantle, the heat will be a little more in excess. It will therefore melt the material, upwell it towards the top. And if the top is not too thick, if the brittle layer is not too thick, it will pierce through it, emerge over here, solidify, and create the ocean crust. So this not too thick is an important requirement. If it were very thick, as it is in Mars, then this kind of a mechanism will not be possible. The mechanism which is called plate tectonics. And the way the Earth's heat is dissipated towards the surface through the mediation of the oceans will not happen. So this is how the Earth works. New material will come here and make, when it is quenched, it will make the new oceanic floor. And as this oceanic floor is pushed on either side, the chasm becomes wider and wider, filled with more and more material, as you see over here. The material is coming right here in the center, as you see in the little spherical picture. And as it moves away from the center, the axis, it cools and becomes heavier, and eventually it will sink beneath the continental material which it had fragmented over here. So this ocean floor which has been created, it dies young. It is nowhere on the Earth's surface older than 200 million years, but as it goes down, all its low density material is scraped off at the sides and piled on to what will become the continents. So the continents become the flotsam. They are made up of the light material which have been scraped off from the skimmed Earth. And what stays here is a slightly heavier ocean and is therefore thinner. So we have found the answer to these questions. Let's go on to the next slide. And we see that the same process does a lot of things to enrich the oceans with mineral deposits. At the axis itself over here, where the material spews, hot material spews, we have hydrothermal vents, and these hydrothermal vents are extremely rich in sulfide mineralization, kind of a resource at which the international community is looking with great interest, and it would not be very long before there would be competitive mining for these, and there is already a race on to acquire certain parts of the ocean in the name of the national world heritage, national share of the world heritage. So all that is happening, and the amazing thing is that this environment where the temperatures are upwards of several hundred degrees centigrade, we have a fantastic biodiversity. And this biodiversity, which you see over here, this is the vent over here in the extreme picture over here, upper one, upper right, second one, you see those biodiversity, and that is powered not by photosynthesis, but by chemosynthesis. Besides, this process of the recycling of material through the ocean floors also allows other kind of reserves to deposit on the ocean floor, particularly this manganese crust, which is rich in cobalt. Cobalt, as you know, is one of the strategic minerals, which is not very plentiful in the earth. And this is something which, again, is being viewed, being eyed by the international community as to where these ferromanganese crusts, which are rich in cobalt, are. But it is this process of being born at the ridge and then dying at the edge of the continent, which were initially rifted by these currents, that a whole lot of geological environments are created bearing mineral-rich provinces, which the community is already looking at with interest, the international community. An International Seabed Authority now apportions certain parts of these seabeds to different nations. India too has its share, and someday the nations which have these particular tracts of the oceanic floor and their science has given them enough confidence of the reserves that are available there, mining might happen. What will these do to the oceanic environment is another matter, and there are grave concerns about what might happen to the oceanic environment with whom our lives are also intimately linked. And we move on to what lies above the ocean floor, its fluid sphere, and it is through those fluid sphere that our immediate concerns are linked. So we go on to the next slide, and we see that how ocean waters temper its solar-powered engine. There's a solar-powered engine in the sense that the Earth, as you see in the lower left corner over here, the Earth is unequally heated by the sun because the flux of sunlight that falls on the equator is higher per square meter than it is nearer the poles because of the curving away of the poles away from the sun. And these cause thermal gradients, temperature gradients, and temperature gradients must allow the flow of heat from higher temperature to lower temperature. On a solid Earth, of course, this may not be possible because materials cannot move, but when the environment has fluid materials, then they move. And this is what moves the atmosphere from the equator here. Hot airs rise, as many of you know, and they move away on either side of the equator. The Earth's rotation, of course, plays another part, which you know is the Coriolis force in turning these into directions as shown over here. And when these winds, which are produced by the thermal gradient created by the sun, they skip the ocean, then they create waves, they create currents, and the oceans themselves are set into motion. But the ocean has very large capacity of heat. The miracle substance, which is water, has high heat capacity, and it is also an excellent solvent, aqua regia, and therefore it has dissolved in it virtually every element that we can conceive of, and therefore the ocean's waters are actually also a storehouse of fantastic amount of mineral materials, although they are in too diffuse a state to be economically viable today. They may be someday when we have the technology to harness them. But we see in how many ways the solar energy, which moves these winds, then moves the oceans, and the oceans in turn move the atmosphere above it in different ways. Like this, the hot air rises and again cools over there. It is blown over the land and it forms glaciers, it forms ice reserves, and creates a gravitational gradient. So you see how the thermal gradient has now been converted into a gravitational gradient so that the material, the water will start flowing, the melted water will start flowing from the higher altitude to lower altitude, eroding the material here, bringing a lot of nutrients and different materials which nourish this ecosystem and finally go into the sea, creating this another cycle. So we can see how the energy is eventually, the energy gained from the sun by the winds eventually transferred to the earth in moving the earth. And every time this happens, part of the energy is lost according to the second law of thermodynamics, but it creates another gradient. So the atmospheric winds, which flow because of the thermal gradient created by the sun, then create gradients in the oceans by pushing it. And the oceans then move materials and create concentration gradients. They also create humidity gradients between the air atmosphere lying above it and the atmosphere farther away from it. And the winds move that atmosphere constantly to create this hydrological cycle. The nutrient cycles are then entrained in this hydrological cycle. And we can see how there is a fantastic variety of loops that flow energy and material through the Earth system. And there is another phenomena that happens, and that is photosynthesis, which in the world's oceans engenders the creation of vast amounts of phytoplankton. And these phytoplanktons, whilst they do photosynthesis, suck up enormous amounts of carbon dioxide from the atmosphere, turn it into carbohydrate in their bodies, and some of it will go deep into the ocean. So these phytoplanktons have two functions. They partly fix the carbon dioxide from the atmosphere into carbohydrates, which sink at the ocean floor, and most of it will be eaten by animals, zooplanktons, and then smaller fish and bigger fishes, and so forth, forming a whole food chain into the oceans. And many of you, even in Punjab, would probably get fish from Andhra and elsewhere, which have been captured from the oceans. So photosynthesis gives another gift to the oceans, and that is the biological pump, sucking carbon dioxide from the atmosphere when it is plentiful over there and exhaling it when it goes down. So this is a cascade of energy flows from the solar energy first through photosynthesis and through actual kinetic energy of the winds. And we can see how eventually a lot of it ends up in moving the oceans. The next slide. The next slide. This shows us how atmospheric and ocean circulation through all these different cycles, nutrient cycle, water cycle, they together create climate. And the atmospheric circulation patterns are important to determine as to how the climate will be, which can be seen here from this cartoon on the right-hand upper corner, that the sun shines the earth. You can see right-hand upper corner. And because of the unequal shining, the earth, of course, the winds blow. Can you hear me?
Yes, sir. Yes.
Yeah. The right-hand corner, the sun shines the earth. The upper one, above that, yes. The sun is shining the earth. The earth gets hot at the equator, cooler at the pole, which drives the winds, and the winds drive the ocean. And all that eventually give the earth a near temperature of about 23 degrees centigrade, which is much more than what it would be if it didn't move and all the energy was concentrated at the equator. Then, of course, the temperature here at the equator will be very high, at the poles it will be very low, but the oceans and the earth homogenize this temperature and give the earth a characteristic temperature, the temperature of our atmosphere. And the physics of it is very simple. The energy falling from the sun is the solar constant, which is the amount of solar energy per unit area, falling on this circular cross-section, which is pi r squared of the earth. And part of it is reflected, which is why we have 1 minus alpha. So this is the total energy received, and the total energy which is actually radiated back to space is proportional to Stevens constant, which is a physical constant, and the surface of the Earth, its temperature, T to the power 4, and a constant epsilon, which determines as to what is the transparency in the atmosphere to these long wave radiations. Because the atmosphere certainly is very, very transparent to short wave radiation, which is coming from the sun, but to long wave radiation, it becomes opaque depending on how much greenhouse gases it has. So this epsilon is the quantity which determines as to what the temperature will be, because temperature will, pi r squared will cancel, T will become equal to this to the power 1 by 4. And we can see that this is going to be controlled by alpha, which is how much of it is being reflected back. It's called albedo, and epsilon is the atmospheric transparency. And ocean atmospheric circulations can alter both these. The next few slides will show as to how they do. Next slide. So we see here, this is a wind-driven circulation of the oceans, and the winds drive from, okay, and you see these are gyres. The gyres, because the Earth rotation turns these currents clockwise in the northern hemisphere, anti-clockwise in the southern hemisphere. And you have these large gyres which are actually created by the winds in that way. There is another kind of circulation which is particularly important in the coastal ocean. And these are the along-shore currents. As the currents along-shore, these are currents along the shore. And these currents move the water in that direction, but the Coriolis force will turn the waters and away from the ocean. And as it turns the water away from the ocean, there'll be upwelling. A lot of nutrients are brought by these upwelled waters, and therefore phytoplankton density will increase here, which will attract the consumers, which are the fishes, over the small fishes, which form the intermediate stage of the food chain. So these are wind-driven circulations, and there is also a density-driven circulation caused by the fact that at the poles, the temperatures are very low, and there is ice formation there, which rejects salt. So the salt goes into the ocean, and the lower temperature also makes the ocean dense. So the next slide will show as to how that happens over here, so that these dense waters, because of freezing of the ice which expels salt and the lower temperature, cause these waters to go down because they are dense waters. And as they go down, of course, they must displace the water over here. So they start moving. And there are places over here, south of Greenland and in Antarctica, where such conditions prevail. And deep downwelling waters then begin to draw up water from the surface through this conveyor belt. So there's a long loop because of the conservation of mass, and the long loop of the cool subsurface water eventually emerges in the North Pacific and comes to the surface, collects all the heat, comes all the way here again, forms a Gulf Stream over here, which keeps Europe warm during the winter, and then loses its heat and downwells again. This is known as the conveyor belt, and the conveyor belt carries thousands, billions of tons of water and heat entrained with them, and therefore it tempers the Earth climate in a very substantial way. So a good question to think is, what is the rate at which this conveyor belt moves? And is this rate important? Is it important for the overall temperance of the Earth's atmosphere? What would happen if it slows down? What would happen if it completely vanishes? Indeed, there was a time not very long ago, about 10,000 years ago, when this conveyor belt stopped. And the next slide will show you how it stopped and how the Earth climate changed dramatically at that time. What happened was that about 10,000 years ago, or 11,000 years ago, when the ice sheets started melting because the Earth's temperature was warming at the end of the last glacial age, a tremendous amount of water flowed through this because there were thick sheets of ice, about 4-kilometer thick sheets of ice lying over this part of the globe. And when it started melting, enormous amount of fresh waters were let loose through St. Lawrence Bay into this region, which is the region of downwelling. And because of the accumulation of large amount of fresh water over here and density stratification, the downwelling stopped. And because the downwelling stopped, this conveyor belt also stopped. When the conveyor belt stopped, this warm current from the Pacific through the Indian Ocean, which actually kept these regions warm, was no longer active. And the temperature started cooling, creating large ice sheets again over here. And because the ice sheets reflect energy back to the sun almost by 100% or 90%, the Earth started cooling again. And the geologists call it the Younger Dryas. That is that period. That was also the period when, again, snow bridges were formed, and it led to human migration from one place to another. So one can see how the conveyor belt rate of movement is extremely critical to the Earth's climate and what it can do to civilizations. In the earlier years, 11th century, in the 11th century, or before now, the human habitats were not that inflexible, and it was easy for people to move. But imagine if such thing were to happen today, how our inflexible world, designed world, will help us meet the new situation. The next slide. Here's another example. I have shown you how plate tectonics constantly reconfigures the oceans, and the plate tectonic forces actually moving South America away from Antarctic. There was a time not very long ago, about 30 million years ago, when this side was joined together and this passage was closed. This passage opened only about 30 million years ago. And when it opened, then the Earth's spin caused the waters to begin flowing almost uninterruptedly since then. And this is known as the circumpolar current. And these currents then cut Antarctic off from the warm Southern Ocean. So here we see the Earth's temperature on the right corner. You see the Earth's temperature through the ages. These are very well constrained up to about 120 million years from various telltale evidences they leave in the sediments and ice cores. And we now know that around this time when the Drake Passage opened, there is a remarkable cooling of the Earth, which has continued since then and probably opened the scene for the emergence of mammals and the human civilization eventually. So you can see that when this current started developing, then Antarctica was cut off, it started freezing, developing large ice sheets over its surface, sending back most of the a substantial amount of the energy received from the sun, and therefore the Earth cooled. So that is how the Earth's cooling happened. And if it hadn't happened, perhaps we wouldn't be there. So one can see how oceans play a very seminal role in determining as to how animal kingdom will develop, and particularly important for our human civilization. The next slide shows this picture that I had been mentioning about 30,000 years ago, our passage from last ice age. And this is actually a picture just about 15,000 years ago, when you can see that large part of this of the globe. This picture is taken from the poles, is frozen and consists of about 4-kilometer thick ice sheet. The temperature of the Earth was about somewhere here at that time. And since then, we have come to a slightly different state of the Earth, when most of these regions which were covered by ice are now built up space, heavily cultivated, heavily used by human civilization, industries, and so forth. As you see over here, this is the designed world on which we live. Here is, so this is the passage, and in the passage from the last ice age to this particular situation, this particular era, which we call Anthropocene, and you can see that there has been an acceleration of the buildup of temperature since about 1900. This is the Anthropocene, and this is how the temperatures have risen. One can actually go back to looking for past climates of the Earth by estimating as to what the temperatures of different ages would be. And fortunately, their evidence is trapped in the ice flakes which fall at very cold regions like Antarctica, and they are buried as such before the next summer melts this layer. So they are all buried under unmelting sequence of falling ice for millions of years, thousands of years. And we have been able to, or science has been able to very accurately determine the situation up to about 300,000 or 400,000 years. And what the picture shows is that every 100,000 years, the temperature of the Earth remains rather cold, as you will see from the picture at the bottom. And then it rises within about 10,000 years and then falls again. So this is how cycle after cycle, the temperature has risen and fallen. The last temperature rise was about 10,000 years ago. And one would imagine, if this picture was to continue in future, that this would be the time for our Earth to start cooling again. But of course, our Earth is not cooling. You see the picture over here. So what does it mean? Is it going to start cooling, or is it going to go up and up and up to a point where much of the fruits of Earth environment and resources that we reap today will become very difficult to harness? The next slide. So we learned from the record I showed here. Now we know why this happens. It happens because, as I showed you earlier, the temperature of the Earth is determined by the solar constant, albedo, and atmospheric transparency. But the solar constant will also depend on how the Earth is configured with respect to the sun. And we now know that because of the dynamics of the planets, the Earth's orbit changes from being circular to a little eccentric with a periodicity of every 100,000 years. It also wobbles on its axis with a precession frequency of 23,000 years. And the tilt itself, which today is around 23, is not a constant factor. It varies from about 22.1 to 24.5 with a periodicity of 41,000 years. Out of all these, it is this 100,000 periodicity of the Earth's orbital ellipticity that apparently coincides with the time taken by ice sheets to form to create this kind of a variation in the Earth's temperature. But we are clearly around here at this time. This happened about, this warming happened around 10,000 years ago. But are we going down or not is something which is our present concern. The next slide. Well, we come back to this large capacity of oceans, its flywheel performance, And we see that, in fact, this is before the Industrial Revolution. This is solar energy that came, a lot of which is reflected back into space and to the atmosphere. Energy storage in the ocean was not very, very large. But today, since the Industrial Revolution, the energy storage in the oceans have become very large. 93% of all the additional energy is stored within the ocean, the additional energy that is actually emitted by human engineering. So this increased heat in the oceans, and there's also an increased carbon dioxide, as the next slide will show. The next slide, as to how the dissolved carbon dioxide is also increasing. In fact, only about 45% of the carbon dioxide emitted by human activities today stays in the atmosphere. The remaining is absorbed by the oceans, but the oceans in turn are becoming more acidic because of that, because the CO2 acidifies the oceans, and that is not very hospitable for the calcareous organisms, the algae and so forth, which constantly fix the carbon into the deep sea. So here is a threat to the oceans that's becoming more and more of greater concern. The next slide shows these complex reactions and how there's a great apprehension that the oceans will stop absorbing the extra heat and carbon dioxide which are emitted by the human activities, and therefore the Earth system will become more and more sensitive to climate change. The next slide. Next slide shows the wondrous world of corals, for example, how they are formed. There's a cartoon here for those of you who are interested. But the corals live on algae. They derive their nutrition from algae. And when the algae are killed by acidification of the ocean, the corals begin to die. So here are the bleached corals. They are an example of what is already happening to some of the ecological systems of the oceans, because it has been trying to mitigate the changes, the increase in heat and carbon dioxide of the atmosphere by absorbing a substantial proportion of it, but in the process, creating conditions for its own very slow debilitation. The next slide. It shows the many adverse consequences of these stresses, which you can see, many of you might be aware: increased sea levels, increased intensity of storms, and so forth. Today is the time to make a list and think of the important issues that arise in designing and implementing a blue economy, which could harness the cyclic energy of the ocean. The next slide shows the gifts of the wondrous ocean, the beautiful waves, the beautiful aquatic world, which symbiotically live with different kind of geomorphic features of the ocean floor. We conserve the gifts of this wondrous ocean. It will be a noble act of humanity. The next slide shows some of the thought experiments one could do to see how we can conserve the valuable treasure troves of the oceans and its dynamic works by making sure that the many gifts that the ocean have been given are conserved, and even as we harness their navigational routes and their energies, their resources, we do it in a manner which is sensible to the very sensitive working of oceanic dynamics. Thank you very much indeed.
So thank you so much, sir, for your wonderful lecture. Wow, what a talk was that. It was really profound and much appreciations the way that you communicate the concepts to the public. I can see the essence of the real science communicator in you. That I did not say in your introduction that you're also part of the Science to People. You founded that mission of the INSA, and later that has also been taken up by Indian Academy of Sciences to bring the essence of the science to the people. You have covered everything that the public want to hear on today to appreciate the importance of the ocean. You started with the origin of our oceans, then how oceans work as a giant thermal sink, and of course the avenues of the rare earth minerals and other blue economy. There are a lot of talk going on in blue economy. The policy is now being framed by the government of India on the blue economy. You also spoke about thermohaline circulation and solar powered engine at the Cascade, all the way from the photosynthesis. Fantastic, sir. And yes, so you also spoke about the origin of Antarctica and the Milankovitch cycles and the opening up of the Drake Passage, and all the way to the Anthropocene, and what are the current problems that the ocean are facing, including the pollution and the carbon dioxide increase and ocean acidification and the coral reef. I really enjoyed your talk, sir. Thank you so much. It was one of the best talk I listened, of late, I can easily say. Now let us go to some of the audience questions. So if you have, you may please unmute and you can ask the questions, whoever is there in the Zoom section.
Yeah, hi, this is Sachi Tripathi. Can I ask a question, please?
Yes, sir. So I would like to say that Professor Tripathi, S.N. Tripathi is from IIT, and he joined for this mission to interact with us all. Yes, sir. Please.
Sure. Ask a question. Can you hear me?
Yeah,
yes, sir.
Thank you, Professor Gaur, for such a talk. And as the organizer pointed out, that it was really a very illuminating talk. So I have one question, that in terms of our understanding of the oceans adjacent to India, that is Bay of Bengal, Arabian Sea, and part of Indian Ocean, where do you see us going? That our understanding of the physical processes, chemical processes, and from the harnessing of the ocean wealth, what do you see? What is our status, and what do you think that should be the priorities in coming 5 to 10 years, sir?
Well, thank you very much. I think the current concern is fueled by the fact that the Earth's climate is changing in a very adverse manner and at a very fast rate. I remember that about 30 years ago, when I happened to be working for the department, the government department in Delhi, there was a proposal for by the world's nations to start mining in Antarctica. I'm taking you a little further away from the oceans, but it is relevant. Antarctica has a land mass which is about 10% of the total land mass of the Earth. And therefore, expectedly, it has 10% of the resources there. And indeed, some of the resources, very rich resources of mineral deposits, are known to exist there. They have already been explored. And there was a clamor for starting mining activities in a small way. And at that time, I took a proposal which was approved by the then Prime Minister Rajiv Gandhi, that we seek a 50-year moratorium on mining in Antarctica till we have a fail-safe technology to make sure that as these resources are mined and used and harnessed, because they will also leave a lot of waste product there, the environment is not adversely impacted. Unfortunately, that particular proposal, which I was discouraged to move by many in the government, at Delhi because they say you will be in a minority. And I counter by saying, sometimes it's a privilege to be in a great minority. But eventually the proposal was accepted. But I'm not very sure as to how long the push towards harnessing more and more of the Earth's resources, including its land and environmentally sensitive land, which is already happening even in our own country, that you might be reading in the newspapers, that there is a push towards using as much of these resources as possible. And they all impact badly at the environment. We already are putting a lot of waste into the sea through our fluvial systems and also through our shipping systems. And I hope that more thought will go towards developing technologies that will ensure that there would be a clean, safe maritime practice, which we can which we can use, and also the many resources of the oceans that we have, particularly the mangrove resources. Many of them around our coast have already suffered very adversely and almost at the brink of extinction, are somehow saved from doing so by reining in the corporate action. So my greatest fear at the moment is that even the Indian Ocean is really threatened by the corporate activities and their future plans that are afoot. And there's a greater concern also that sea level rise would probably, very adversely impact the low-lying islands. Particularly, I don't know what will happen to Lakshadweep, for example. Bangladesh will suffer very badly, although it's not a part of India, but of course, we need to be, as scientists, we need to be concerned with humanity at large and do nothing that will adversely affect the livelihood and living conditions, habitats of the others. So what I feel is that we have enough knowledge. Now we need to develop technologies which are sensible to the very sensitive environment of the coastal ocean, and design of policies which will make sure that we do not overexploit these systems so that their capacity for providing the ecological services on which we are so abjectly dependent are not lost.
Okay, any other questions from the audience? You may please unmute and you can ask directly. I can see one question from the chat box. Dr. Subhranshu Bhushan Rai is asking, sir, there is a huge amount of microplastics in the world's oceans, which is a serious threat to its health. How can the problem be addressed?
Well, the first thing is to ensure that we resort to designing our packaging and other practices which are eventually conveyed by steamers, ships from one destination to another, so that they are not necessarily thrown in the oceans. Make everyone sensitive to the fact that any waste discharged in the ocean is eventually going to rebound on us by, in some way or the other, by hurting its fisheries, by hurting its other kind of services, etc. And developing technologies to collect and bury these pollutants into places where they will not hurt our ecological system services.
Any other questions? You may please unmute and ask directly.
Hello.
Yes.
Hello, can I ask one question?
Yes, please.
Hello, Gaur sir. This is Madhav from IUAC. And I have a question like habitat zone. Habitat zone is like based on the temperature. And now this is considered because we observed our Earth exists. That's why the particular temperature we decided. Sir, can you hear me?
Can you
Hello?
repeat your question again? Are you talking?
I was talking about the habitat zone.
The heavy side. The heavy side.
Yeah, right. The
In
where
the
life exists.
in the upper
So
atmosphere.
it is. Sorry.
This zone in the upper atmosphere, or
You mentioned this the where Earth exists. This is the habitat zone because temperature.
the habitable zone.
Right.
Yeah.
So it is decided because we observe there Earth exists, or there are many regions behind it.
Reason behind what?
The flux. Like Earth exists, we think that okay, habitat zone is this distance, this much is flux.
No, I tried to explain it in that slide,
Hmm.
and if Felix can put that slide again, I can explain it. The habitable zone is decided by the temperature in space around a given star. So if we are talking if a particular solar system, a particular stellar system, we know its luminosity. We know the luminosity of the parent star from its size. And from the luminosity, one can work out as to what the flux would be.
Right.
Yeah, go back to the, further back. Yes, that one.
That one.
So you see over here, the total energy flux at a distance r from a star, L, the luminosity is L, right?
Right.
So the flux will become at any distance from a star, given its size, luminosity can be calculated. The flux will be L divided by 4 pi r squared.
No.
And the flux, we have a physics-based calculation for the flux that is proportional to the 4th power of temperature multiplied by Stevens constant sigma. So given L luminosity, we can calculate T, which will be L upon 4 pi r squared sigma to the power 1 by 4, right?
Right.
And when you plot that and you draw this curve, which is the blue curve, habitable zone, as those where the temperature lies between 0 and 100 degrees centigrade, then you get this habitable zone.
Right. This I understand, sir.
So it is the habitable zone has not been drawn with the Earth in mind. The habitable zone is first drawn, and we see that the Earth happens to be, fortunately for us, well, we wouldn't be here if it wasn't. It happens to be within that zone. So that explains why there is no liquid water elsewhere in the solar system.
Okay. No. Other question is like start moving. So do you think that the habitable zone will change to other planet?
Very good question. The habitable zone will also depend on the life cycle of the star.
Right.
For example, 3 billion years ago, our sun was only about 40% as luminous as it is today, right? But still, fortunately, still with that 40% luminosity, right? There was something else that made this zone habitable, and I should have explained it, but that would have become a little more complex. The habitable zone is also determined by how much green gases you have. The epsilon of that other. Unfortunately, the epsilon was very high at that time. Low at that time. Transparency was low because the atmosphere was suffused with carbon dioxide. So even as the sun took about 1 or 2 billion years to come to its present stage, of luminosity. The carbon dioxide flux from the atmosphere to the oceans was also regulated by the oceans, incidentally, in such a manner that the temperature is still remained within that limit.
Right. Thank you, sir.
We have a
Excuse-
the chat box by somebody called Shotgun. Shotgun is asking, what are your thoughts on artificial islands being created by China in South China Sea, and how it can lead to harm the EEZ, that is exclusive economic zone, for other bordering countries? What are your thoughts on this?
Well, the little island that is being created is only about 2 or 3 square kilometers. So it is not going to make substantial difference to the economic zone. And fortunately, the few hundred meters of economic zone, or few thousand meters of economic zone that it may thereby extend is not going to impinge on any other country, because there is no other country south of Sri Lanka within that range. But the other part of the question is how desirable it is to reclaim lands from the sea and then colonize it is something, which I do not think has a very clear answer, because we haven't done, and I don't think that the Chinese or the Sri Lankans have done any analysis as to what would happen to the marine ecological system if you do this and you start all your secondary activities. I mean, they will become primary, but there will be activities which will be promoted by the existence of this island. How will that happen? How will that work out? That is the environmental impact assessment. I have not seen any mention of this having been done by anybody, which is unfortunate, because it could have been possible that you would say the environmental impact will be very small. But we live in a world where we like to be told, we like to know, we like to understand that we are guided by knowledge. But this has apparently been done without developing any knowledge of what the impacts could be. There will be some impact, certainly. How severe will it be? Will they be irrecoverable or not?
Excuse me, can I ask one question, please?
Yes, please.
So first of all, congratulations, sir. It was such a very informative talk. I have thoroughly enjoyed it. So I have a small question for my curiosity. So you have already mentioned about the radioactive decay, which about the Earth internal energy. So does the rate of decay process stay same over time, or it changes? Was it same, like was in billions year ago, or it's slowing, or what is happening? So is there any changes regarding the radioactive decay process?
Okay, so if you know the law, which is fairly well established about radioactive decay, that the rate of radioactive decay is proportional to the existing number of those radioactive nuclei. And with time, as more and more of this material decays, less and less is available, and therefore the rate will also change. It will be less. Does that answer your question?
Okay, sir. Thank you, sir. Thank you, sir.
Sir, what are your thoughts about the blue economy policy, which is being drafted by Ministry of Earth Sciences? Do you identify any priority areas where the document should emphasize on?
I have not seen that document. And I don't know if it exists already or is it being worked out. But it would be interesting to know as to what the policy would be. But I would guess that, or I would wish that we should all really start thinking and contribute to, I mean, whether the policymakers take our advice or not, but it's a scholarly exercise. What are the what are the problems of the ocean? What are the resources, environmental issues that should be conserved? Resources, and we know the resources that they are. And we also know that there are already mining instruments which have been engineered that can harness the resources, even bring them up from 5 kilometers below the surface of the earth. And what it will do to other aspects of the sea is a moot question, because I don't think that's been studied so far. And the environment, which we impact by what we do on the land, coastal lands, and what we do through shipping, and what we do by emitting greenhouse gases into the atmosphere, which is eventually going to impact on the oceans. The oceans are going to rise, they're going to become warm, they are going to become more acidic, and therefore less able to support the ecological services that they give to humanity.
We have one question from the chat box by Pankaj Baghel. Sir, you mentioned that there was a proposal to start mining in the ocean. What is the status of this? And also your comment on the loss to ocean ecosystem due to ocean mining, the ramifications of ocean mining.
Well, the ocean mining is largely going to be focused on ferromanganese nodules and ferromanganese crusts, and sulfide mineralization at the mid-oceanic ridges. I think these three are the objectives of ocean mining, main objectives. The ferromanganese nodules, which lie at a depth of about 4 to 5 kilometers deep in the ocean, they lie in an environment where for several tens of meters, there is very soft mud. And the instrument which is going to scoop these materials and eventually send it to the surface is going to stir a lot of this mud when it starts working. You can imagine what will happen to the deep living habitat of these regions. If you Google, you will find the deep living world in the oceans. And one can imagine as to what would happen to that. But one could carry on these exercises. One could actually do some kind of calculations and show that if you mine so much of an area, how much is going to disturb, how much of the material is going to be sort of churned into ocean and made it muddy and so forth. Because, you know, all these systems have been stabilized over millions of years, and we are going to upturn them over just a few decades or so. So what will happen to that? So that is as far as the manganese nodules are concerned. Then there is also a rush towards, it's not an overt rush at the moment, it's a covert rush, but there's already, nations are already trying to compete for areas of the ocean near the mid-oceanic ridges where these sulfide mineralizations. Yes. Those sulfide mineralizations are also surrounded by very exotic biodiversity, which I mentioned. Biodiversity which is powered not by photosynthesis, but by chemosynthesis. And scientists yet to have to learn a great deal about how this chemosynthesis sustains large biodiversities and how they interact, if at all, with the photosynthesized biodiversity. So how does in the totality of the oceanic environment, how do two systems interact? If we start disturbing these even before we have developed these pieces of knowledge and found out as to what their role is, before we destroy their role, it could be a matter of grief. But technology is something, technology for exploitation is easily assembled. technology and science for assessing the impact is much more challenging because it's a very complex system. And whatever you do to one part of the system impacts the other part of the system. So it's a large coupled system, and analysis is a very challenging task. It is to those that we should turn our scholarly attention.
Yes, Dr. Milan Kumar Sharma, do you have any question?
Yes, sir. First of all, sir, I just like to congratulate for this wonderful lecture, sir. I have a query, sir. Actually, some of the scientists are in the opinion that thermohaline circulations of the major oceans in the globes are slowing down, sir. So in this view, sir, what is your opinions for this particular process, and why it is slowing down, and do you agree with that particular opinion, sir?
Well, I gave you an example of a slowing down in the about 11 centuries ago. That was the Younger Dryas. The concern that the conveyor belt is slowing down arises from the fact that what drives it eventually, and it's a thermodynamic engine in a sense. So what drives a thermodynamic engine is the difference between the heat source and the heat sink. And which is the gradient. And you can see in a common sense way, the higher the gradient of any system, the speedier will be the flow. If we reduce the gradients, for example, in a stream where the gradients are high, the river velocity is very fast. But when the same stream is turned around and around to make oxbow lakes, then the velocities are slowed down. So the apprehension is that the warming of the atmosphere, can you hear me? Hello?
Yes, sir. Yes.
Yes, sir.
The apprehension is that the warming of the atmosphere is going to reduce, or is already reducing, this gradient, and therefore slowing down the thermohaline circulation, which is this conveyor belt, and therefore slowing down the transfer of materials from excess regions to deficit regions, and therefore creating instabilities which could build up perhaps to catastrophic limits.
Thank you, sir. Thank you very much.
Okay, so we have got lots of questions in the chat box. So because we are running out of time, so I will just pick the last question from the chat box. And this question is by Mayank Lambam Surdas Singh. Sir, what is your view about dumping of radioactive waste substances into ocean water?
Well, the dumping of radioactive waste in the ocean waters is doing the same thing to all the aquatic world as dumping of radioactive waste near our house will do to us. And if you have any concern for the aquatic world, and let us not forget that a very large population of the planet actually ekes out its living and also subsists as food on this world, then you can imagine as to what grievous losses we will suffer on account of that. Apart from the fact that this can only be done by stealth, and any act of stealth is, if you believe in any kind of morals, is morally reprehensible.
All right, so we have Ashish Haldar. Would you like to ask the question? I can see a question here. You can unmute and ask the last question of the day. Ashish Haldar. Dr. Haldar? Okay, I can read out that question. I can see that in the chat box. Will the life forms will adapt to temperature rise, as we can see that life is also found near the oceanic vents where temperature is way too high and the gases are in excess? His question is about the adaptability of biological species.
The life systems have always adapted to varying environmental situations. throughout the Earth's history. And that is how we have moved from single cellular organisms to hominids. So there is no question that the life forms which evolved by mutations would adapt themselves. What kind of life forms will it be is very hard to say. The second thing is that that process, however, is much slower than the changes which are being wrought. And therefore the changes could overwhelm that process and cut off that possibility of adaptation, simply because it takes a little longer, whereas the changes that are taking place are much more rapid. So it is the rapidity of change which is a cause of concern.
All right. So thank you so much, sir, for your wonderful lecture. And we have vastly expanded that we planned initially for 1 hour lecture, and now it is 1.5 hours, 12:30 now. Thanks a lot from Central University of Punjab, and all on behalf of all my colleagues and friends. And more than above all, our Honorable Vice Chancellor, it is actually his initiative to organize this event. Before concluding to go into the next session, I would like to ask our Honorable VC, sir. So would you like to comment a little bit on this talk, or should we go to the next? Yes.
I'd not like to comment. In fact, as you have seen from the presentation of Professor Gaur Sahab and his academic and research accomplishments, I don't have authority to comment on what he has said actually. We all know that he is one of the finest scientists that India has in the contemporary world. And, I had the opportunity to interact with him for the last 2 decades. And he has been kind enough to deliver convocation address in Mijam University, where I served earlier, and then also in Dr. Hari Singh Gaur Vishwavidyalaya. And in fact, it was day before yesterday only when I requested him to deliver talk today, and he very kindly agreed. So I'm thankful to him, and I'm sure that all the audience are immensely benefited. And today's lecture, because this Google Meet has some limitations, so directly not many were there, but you see the data in YouTube, and this was circulated. What Mr. Gaur Sahab has tried to convey the message, the take-home message is that we should consider Earth system science as as one unit, and all that affect our habitat on Earth. The oceans, the land, the atmosphere, hydrosphere, of course, oceans, and all constituents we have to see in entirety, and see that whatever we do on one component of the Earth system science, that does not affect the other component, because all are interconnected. Now, as I said on the other day, that what we see is that there are different days observed, and those are seen in isolation. But what Mr. Gaur has today showcased is that the oceans, whatever we do on the land, that adversely affects the ocean. And when the health of ocean is destroyed, naturally the health of land will not remain intact. Land will not remain healthy, and it will not remain habitable to the humankind. And it's not only that, the oceans have been very useful right from the start of civilization. And if we see the, the interaction of one nation with the other nations, the sea was the dominant route. But now, due to our, the modernity and the so-called progress, and everywhere somebody somebody said that some artificial thing is created into the ocean, whether the health will remain intact. Artificial thing, whatever we have made, made not using raw material from the Mother Earth, that have always adversely affected the health of the Mother Earth. And whatever material taking from the Earth, of course, if we go deep down and take the geological materials that we take, those and we with latest technology, we make them not biodegradable, but otherwise, our entire civilization was based on perfect adjustment with the nature, and so as with the oceans. Now, ocean's health is also being destroyed at alarming rate, and there are certain pockets on the oceans where the life is not possible. Life cannot exist. They have become so toxic. Their turbidity has become so high, and so on and so forth. So therefore, there the life is not possible. And as we all know that human civilization, we cannot imagine without the support and without sustenance from the oceans. So oceans are integral part of the Earth system science, and they affect the entire cultural discourse that we have with the nature, and the entire, and the continuity of civilization on the Earth depends on the healthy existence of the oceans. We are now facing the vagaries of the oceans, and we have cyclones quite often now, and very erratic rain pattern, and the overall the climate change, which Mr. Gaur has talked about, and submergence of various land areas that have happened in the past, as well as we can see several cycles of marine transgression and regression that have affected the evolution of life on the Earth, that have affected the existence of life. Several, thousands of species became extinct, but due to episodic nature of evolution, suddenly other group of organisms evolved, species evolved, and that kept the tempo of evolution high. And if we want the continuity of this evolution, if we want to continuity of human civilization on the Earth, we have to take care of every component of the Earth system science and every component of the habitable zone, as Professor Gaur very rightly depicted, that because as on date and in near future, we cannot imagine the existence of life on any other planet or on any other solar system. So therefore, our most bounden duty is to make equitable zone really equitable, and this remains equitable to us. That should be endware of all of us. And this maintaining balance with the nature, and the realizing the adverse impact of climate. This should be, in fact, part and parcel of everyone's life, and everyone has to care. Not only the government, not only the NGOs, but the education institutions, all other institutions, NGOs, government, individuals, that are very important, because individuals constitute everything. Institutions in institutions there are individuals, in government there are individuals, in NGOs there are individuals, in industry there are individuals. So if every individual is really well aware of this and really functions and behaves with the Mother Earth, with the nature, as we have been behaving for the last 10,000 years, then only we can see that equitable zone really remains equitable. I would like to thank Professor Gaur Sahab again for delivering a wonderful talk, thought-provoking talk, and I'm sure that the participants, they have received some new insights, and new ideas have emerged in their mindset to take research in this area, and take the research on oceanic sciences at the higher pedestal. I'd like to thank Dr. Felix and all others who have been privy to and who have given their time and energy for organizing this event. And in fact, Dr. Felix is always active in organizing things like this. In fact, it is he who reminds me all the time that now on this date, we have this day, so let us have some program. Yes, institutions, grow only with the support of all its constituents. Milan and Jiten, they have been very helpful in organizing this event, in disseminating information about this today's talk of Professor Gaur sir. So my compliments to everyone who have participated and listened to Professor Gaur and have really actually benefited from his deliberations. So thank you. Jai Hind, Jai Bharat.
Thank you so much, sir, for your wonderful summary and your thoughts about Professor Gaur's talk, and especially the collective responsibility that you highlighted and the holistic approach about the Earth system science. Very important two messages that you highlighted on your summary and your thoughts about this program. And from the family of Central University of Punjab, sir, Professor Gaur, from the bottom of our heart, thank you so much for being part of our today's function, this World Oceans Day. So with your permission, sir, allow us to go to the next session of the program. It's a quiz competition. So let me share the screen with the rules and regulations, and then I will go to the quiz. So this is the International Oceans Quiz. So all the questions are based on oceans, and also many questions are based on Professor Gaur's today's talk. So those who attentively listen to his talk, you can actually score more marks in it. So this one is, of course, is part of the university's effort on dissemination. So this is more like an infotainment activity rather than a quiz competition. So we conducted several quizzes. The last one was on 5th of June, which is only 3 days before. And today's Professor Gaur's talk, he highlighted about points about the paleoclimatology. And we were fortunate to have a presentation by Professor Vandana Prasad, Director of the Birbal Sahni Institute of Paleosciences in Lucknow, the last environmental day, which is just 3 days back, including the international quiz competition. So today's quiz is Oceans Quiz. Instruction is that it's open for everybody, including teachers, students, foreigners, unemployed youth, everybody. So winners, the first 3 positions will receive certificates. And of course, there won't be any cash prize, but it doesn't matter. It's an achievement, It's an international quiz. And the quiz is conducted through a site called menti.com. And answering here in the Zoom or in the YouTube chat box will not get you any point. You have to go to this particular site, menti.com. I've already given that in the chat box. You have to click on that site, and then you can attempt this quiz. And when you go to this menti.com, it will ask you to enter a nickname. Please do not enter the nickname. It has to be your real name, so that, whichever the name you want to be printed on your certificate, so the winning certificate. So it has to be your real name. No nicknames are allowed. Okay, so that you have to be careful. One important, interesting aspect of this quiz is that it has got timed questions. So, when the quiz starts, the question will appear, and the participants need to answer before the countdown ends. So it's basically 15 seconds, but the response time will also be measured. So the faster you respond, you will get more score, like Kaun Banega Crorepati, and countless number of TV quiz competitions. So that is why, if you think that you can Google the answer first and before answering here, will not get you marks. So be careful to answer faster. So because even the response time to the microseconds are being measured by our program, and wrong or no answer will give you 0 points. So no problem with intelligent guessing, which is absolutely fine, right? And after every question, there will be a leaderboard declaring who tops the competition with the exact points. And at the end of the last question, the winner is declared. And after the quiz, so the quiz contains only 15 questions, and most of the questions are true or false. So it's actually simple, but it's thought-provoking. Each questions were framed thoroughly to give you some more insights about the Oceans Day's significance, and especially the talk by Professor Gaur. After the quiz, please join back here in the YouTube to hear the final concluding remarks as well as the formal declaration of the winner and many other information. So please don't stop it with the Menti alone. Okay, please come back to the YouTube. And if you are watching this program through the Zoom, I can see many of the participants. Please do not annotate in the Zoom, or please do not speak out answers. And I repeat, if you answer in the YouTube chat box like A, B, C, D, you will not get any points. You have to go to menti.com. So that is what I would like to emphasize. The quiz is going to start in the next 4 minutes. So please go to the following website using any standard browser, using your computer or mobile device. The website is www.menti.com, MENTI.com. It will ask you to enter the code. The code is 19 51 50 13. 1951 5013. I'm giving some buffer time for others to join this quiz competition. There are so many people here. I can see that more than 600 live viewers of today's morning talk in the YouTube. Unfortunately, we couldn't take up all of your questions. There were several of the questions in the chat box. Thanks for participating in this today's World Oceans Day special lecture and the quiz competition. So please go to this site menti.com and enter the code 19 51 50 13. Let me go to that site. I can see that a large number of people already in it. So I'm just waiting for a few more people to join. The code is 19 51 50 13. That is 1951 5013. You would need to go to the menti.com website. You can use any standard browser, either on your mobile phone or on your laptop or a computer, no problem. Open a browser like Google Chrome or Edge or Firefox and go to this site, menti.com. I will ask you to enter the code. The code is 1951 5013. And please do not enter your nickname. It has to be your real name. So last few minutes remaining. So let's start the quiz within 1 minute. I repeat once again, menti.com and use the code 1951 5013. Competition is completely open for everybody. No age barriers or educational barrier or nationality, even for foreigners are allowed. So we can see a very large number of people here. Only 75 are shown in this screen. So last 30 seconds, the people are still increasing. I can see the count is increasing. Only 15 questions. All questions are about oceans. All right, let us begin today's quiz competition. So the first question is, let us start the quiz and be careful to answer faster, okay? So don't check out the answer in the Google, you will be losing the points. So that is the advantage of this particular Menti quizzes, okay? So response time, faster respond, you will get more points. Let us start the questions. So first question of the day is, since the start of industrial revolutions, oceans have become 30% more acidic. True or false? Majority of you answered true, which is right answer. Yes, ocean acidification has been highlighted by Professor Gaur's talk. And you know that's this pH is in log scale. So even a very small dip from 8.4 to 8.2 can give a huge impact. So it's 30% is the more acidic. Now acidicity is really impacted, and we can see that in his presentation he highlighted even the coral bleaching, because the algal symbiont that does the symbiodinium is being affected because of the ocean acidification. Very good. At the end of this first question, we will see who is topping this list. We can see that Jay Krishnan VM is very regular with all of our quiz combination. He is the fastest to answer, then closely followed by Joshna and Sagar Ashok Yadav. Very good. Let's move on to our second question. Black smoker is what? Submarine coal deposits, hydrothermal vent. Many of you thought it's a coal deposit because it's black color, right? No, it is basically the smoke is coming from the hydrothermal vent, and hydrothermal vents are also highlighted in the talk by Professor Gaur today. So it's hydrothermal vent. Another name is called black smoker. At the end of the second question, we can see that Dr. Shatrughan Singh very fast answered, and leaderboard has been changed. Yes, Jayakrishnan, then Shatrughan Singh, and then Ashish. Very good. Let's go to the third question of the day. Pacific Ocean is wider than moon. True or false? Most of you said yes, true, which is right answer. Yes, so you might have heard of this giant impact theory, that the moon itself is created as a chunk, emitted, taken out of this Earth, the surface, where the giant crater formed that is called Pacific Ocean, with the impact with Theia, the Earth-sized planet. So Pacific Ocean is indeed wider than the moon. There is one fun fact which we should all remember. So at the end of this third question, we can see that Jayakrishnan VM is topping the chart. Yes, so still Jayakrishnan, then Anuj Bhadral has come to the second, and then Hani Kumar is now third. Hani Kumar is again coming up, so he's also quite regular in all of our quiz competition. The fourth question. Sea ice is drinkable. That means salinity, you can actually, it's potable. True or false? Most of you said false, but no, it is true. It is, again, there is a very interesting fact. It's basically, of course, the sea ice has got different salinity, but by and large, the average salinity of sea ice is extremely low. It is absolutely fine to melt it and to consume it. The reason is that as the sea ice gets older, the salt gets into the extremely small pockets, and that salt gets ejected into the sea. By the formation of sea ice, the salinity of the ocean gets up. So sea ice is perfectly drinkable if you melt it. So it's actually true statement. And at the end of this round, let's go back and check out the leaderboard. So we can see that Mukilan M answered it very fast. And is there any change? In the first three positions are Jayakrishnan, Hani Kumar, and Nirmala. Nirmala has come up in the I guess the Nirmala is the same Nirmala who won the prize in our Environment Day question. So going to the fifth question, ocean surface reflects the sunlight and IR radiations back to the space, helping the planet to cool down. True or false? True. Many of you said, but that is not the right answer. Of course, oceans are giant thermal sink, a point highlighted by Professor Gaur's talk today. Of course, almost 99% of the excess temperature of the Earth's atmosphere is being sucked up by the ocean. Oceans are getting warmed up. It's a giant thermal sink. So that is why it is a wrong answer. So yeah. At the end of this round, we can see, go back to the leaderboard, we can see that Jayakrishnan couldn't answer it. Rahul Mukherjee, Hani Kumar, and Mohit Baniwal got it right. And now Hani Kumar is now on top. But after that is Mohit Baniwal and then Jayakrishnan VM. Very good. Let's go to the next question, which is number 6. We have better maps of Mars, the planet Mars, than our oceans. True or false? True. Majority of you answered it right. Correct. We have got higher resolution maps of Mars and Moon comparing to the ocean. So we don't know much about our own oceans. We know more about Moon and Mars than our oceans, right? That is actually it's alarming, and that shows the lacunae of our knowledge and the reason for prioritizing the ocean and ocean research. And at the end of this round, we can go back and check out the leaderboard. Jayakrishnan VM got it right, but Hani Kumar and Mohit Baniwal missed it. So we can see that it's fastest is Jayakrishnan, followed by Anita Suresh, Parat Sekar, and Rahul Mukherjee. See, everything is twisting, right? The leaders are completely changing with every question. Very interesting. Going back to the 7th question. Sound travels much slower in oceans than in air. True or false? Most of you said true, which is wrong. It is false. Of course, it is the opposite. Sound travels so much faster in the ocean than in the atmosphere, you see. So it's the speed is 1435, that is 1435 meter per second, which is approximately 5 times the speed of the sound in the atmosphere. And that is why the sonar plays a major role in the oceanic communication, especially in defense systems, and that is the reason for it. Now, going back to the leaderboard at the end of 7th round, which is almost like halfway mark, we can see that Hani Kumar and Jayakrishnan got it right, and though the speed is a little bit lesser, Jayakrishnan still on top, Rahul Mukherjee and Hani Kumar. 8th question. Ocean is blue because seawater absorbs the blue color in the visible spectra. That is why ocean is blue. True or false? Seawater absorbs the blue color in the visible spectra. Reason for ocean is blue. So almost half, and majority of you said true. Again, this is one of the very basic concepts that we learned in school. That is false. Actually, the ocean is blue. The reason is that it actually not absorb, but it actually emits the blue light, because it's actually absorbs the red, orange, and yellow. The long lambda, long wavelength, and it actually, because it absorbs the long wavelength, the shorter wavelength is being gone out, right? That is why it's a blue color, and the deeper you go, it becomes deeper blue, and then of course the photic zone, and after photic zone it becomes pitch dark. So majority of ocean is dark, if you go at a depth. So we'll go back to the leaderboard once again. Rahul Mukherjee got it very fast, so as Anuj Bhadral, and yes, Jayakrishnan VM is still topping, Rahul, then Hani Kumar. Let's go to the next question, which is 9th question. It's estimated that 1 to 2% of the internet data is transported undersea via giant optical cables. True or false? So most of you said true, which is no. Again, that is what, right? This kind of questions allow something which is completely unexpected. Friends, 99% of the data is being transported by these cables in the ocean. Oceanic cables play a big role on the internet communications, which also I came across this particular fact very late. It's really important to know that the oceans really play a huge role. It's something like optical fiber of a soda can thick fibers which are laid in a flat surface of seabed, and that is why people say that the data is stored on the cloud, the cloud computing, but that is a misnomer. It's not a cloud, it's the ocean. Ocean is very, very important for data transportation, especially the internet. You're watching this one all because of the ocean, right? Going back to the leaderboard, we can see that most of the leaders couldn't answer it. We got Abhijit Nayak and Anita got it faster. Abhijit Nayak got it very fast. Still, Jayakrishnan is on top. Anita, Suresh Parsekar is second. Rahul Mukherjee is third. Next question, 10th question. We have explored and mapped only roughly 80% of world's oceans. True or false? Well, it's 50-50. Majority of you said true, which is no, it's false. The opposite is true. 80% of the oceans remain to be mapped or explored. Only 20% has been, explored in a rough manner. But actual estimates say that the real, intricate exploration happened only 5%. But if you include all kinds of exploration, then 20% is the maximum limit. So 80% remain to be explored. So it is not that we already know 80%. So it's incorrect. So going to the leaderboard, we can see that. We can see that Jayakrishnan is still on top. One of the participants who asked a question, I can see Surdas Singh is also now coming up here. Anita and Rahul are second and third positions. I'm going to the next question. 11th question. Humanity discovered planet Uranus before we found Antarctica. True or false? True, yes, correct. That is also a very interesting fun fact. It was way back in 18th century that the scientists discovered this Uranus, but it was in 19th century that we could able to spot Antarctica, So yeah, we have lots of more things to do by ocean exploration, friends. And going back to leaderboard, we can see that Jayakrishnan, VM, Maya Mangalam, Surdas Singh, all these are all the participants are doing fantastic, good job. Not change in the first 3 positions. Next question, which is 12th question of the day. Longest mountain range in the world is Andes. True or false? True, which is incorrect. Andes is not the longest. So, oceanic ridge are really long, especially the mid-Atlantic oceanic ridge, which actually spans not just an Atlantic Ocean, but it actually goes throughout the world's ocean, which is almost 8 times the length of the Andes. Andes is, of course, the longest mountain range in the land. But if you look at the planet Earth, the oceanic ridges are the really longest, So it's basically, underneath the ocean, this kind of ocean ranges, you can see that, especially in the Atlantic and Indian Ocean regions. So it is false. Going to the leaderboard. Anita Suresh Parsekar answered it very fast. So now Anita is number 2 and Rahul Mukherjee is number 3, followed by Kumar. Very good. Going to the next question. 13th question. More than 80% of the world's volcanoes are in the ocean. True or false? True, yes, correct. 80%, friends. That's a large number, so volcanoes are underneath the ocean. So as the hydrothermal vents. So going back to the leaderboard, we can see that Kishan Sharma got it very fast, this answer. And Jayakrishan VM is the fastest indeed. You can see that there's no change in the first 3 positions, which is Jayakrishan VM at 10,715 points, followed by Anita Suresh Parsekar, 10,519 points, and then 10,401 point Rahul Mukherjee. Very, very neck to neck, competition with all these 3 positions. So now we'll go to our penultimate question, which is the 14th question of the day. Pacific Ocean is expanding each year while Atlantic Ocean is shrinking. True or false? Most of you said true, which is incorrect. It's actually a false. It's the opposite is true. Because of the tectonic movement, the Pacific Ocean is actually going towards west, towards Asia. And because of this movement, Atlantic Ocean is expanding while Pacific Ocean is shrinking, and after many, millions of years, we can even see that the America might collide with Asia and, that area near Japan. Very interesting. So this is what the questions will teach you something interesting, isn't it? There are so many things that you can take home and learn. Pacific Ocean, is actually shrinking, right? So you can see that Anita Suresh couldn't answer that. So that now that the second position is gone, Rahul Mukherjee is second, Kumar is third now. Very good. Now the final question of the day, 15th of today's questions. So this will give us who is the winner. The Earth's oceans are filled with massive, hollow, worm-like entities called pyrosomes that can grow as big as sperm whale. True or false? Yes, pyrosomes do exist, and these are giant tube worms, and it's as big as a whale, sperm whale is massive. And the existence of these pyrosomes became to know only very recently with our surveys with submarines, So many things we don't know, what kind of life are there in the depths of the ocean. The entire, knowledge, ocean of knowledge is left in front of us to be explored. And that is why oceans matter immensely, friends. So now going back to the leaderboard, the final leaderboard that will declare the winner of today, we can see that Jayakrishan VM is the winner of the day. Very good, Jayakrishan VM. Congratulations with 12,659 points. Closely followed by Anita Suresh Parsekar with 11,491 points. And then Rahul Mukherjee is 11,379 points. Congratulations to all of you. And I really enjoyed this quiz. It's really interesting. Let me take a screenshot of this page so that I have in my record. Yeah, thank you so much for watching this quiz program. So for formally announcing the winners, I would like to call upon Professor Raghvendra P. Tiwari, sir, our Vice Chancellor, and to speak the concluding remarks of today's session. Over to you, sir.
Dr. Felix, I think he's not in.
I think he's not in. I cannot see him here. Yeah, doesn't matter.
You can call him.
All right. I'll just see it. Okay. So yeah, you can discuss something. Jitendra. Okay. So you can speak a little bit on that.
It was really wonderful talk today we had from Professor V.K. Gaur, and it was like he very nicely explained to the audience. It is like any general public can get lot of information about the ocean. Like Dr. Felix was talking about while the quiz competition, he was telling that many things we don't know about our own ocean. It is really true. If you look at the vastness of the ocean, it is like nearly 70%. So we don't know much about the ocean, and it is like for the academician, educationist, everyone actually, we should know about our own ocean, and also how the ocean is playing a major role in terms of climate and other things, whatever we see. So it's like we should educate all our younger generation, and what is like as a human, how we can contribute towards the climate change and the changes what we are seeing in the ocean. So it is really interesting, and in the talk also, you was talking about the water, like how we are how Earth got a lot of water and in the ocean.
All right. Thank you.
It's really interesting talk, and we had a very nice session, and quiz competition also, it was really wonderful. Like many people participated, and really nice questions were there. And I hope many things we learned from this today's session. Over to you, Felix.
Yeah, thanks, Jiten, for moving on with that today's session. I had a word with Professor Tiwari, and he's on an urgent meeting, so he could not join back in our concluding session, and doesn't matter. So congratulations to all the winners: Jayakrishnan VM, Anita Suresh, Parsekar, and Rahul Mukherjee. So you will all be getting the certificates. And if you have turned in the feedback form, which I shared that in the YouTube, you will be getting the participation certificate for today's program. Thank you so much for everybody. So allow me to share my screen. I have a last message to say. Okay, so could you please rise for the national anthem? This is the last, item.
Felix. Felix.
Yes.
Okay, so actually few persons they joined in the session. Okay, after this also we can talk. You can start.
Yeah. Okay, so please rise for the national anthem. Okay, so let me play the anthem. Thank you, everybody.